Welcome, welcome everyone. I'm excited to present this training to you today about adding an autonomous AI coding agent to your software team. So much has been said about AI and AI-driven development that the overall question is, okay, what's it going to look like? Can I actually delegate a feature to the computer? So we're going to dive into that today, and I'm excited to do it. We have a lot of information to cover. Quick agenda. Um, we're going to talk about AI coding tools first and just do a quick overview. And then we're going to talk about DevOps for AI-driven development and how a DevOps automation is complete and compatible with an AI-driven development workflow. And then we're going to talk about what changes in your requirements analysis whenever your goal is to effectively delegate to the computer and add a AI coding agent to your team. I will, from a philosophy perspective, I approach the AI coding tools as another piece of machinery. I don't expect any of this to be actual intelligence as if there is something uh, autonomous with agency on the team. It is a piece of machinery. It is a computer. And as any piece of machinery, it requires a person to operate it. There is no world in which it somehow magically does something by itself without a person operating it. However, if I can take the simple features or the simple changes and almost make them automatic so that my engineers can focus on the more complicated or the more novel things, then that's a win. That's a win. So that's where I'm coming from. All right. Um, as point of introduction, my name is Jeffrey Palermo, and I am the chief architect for ClearMeasure, a full service software architecture and engineering firm that empowers our clients to deliver world-class results. My latest book, The Five Pillars Leadership for Effective Custom Software, is been out almost a year now. If you take a screenshot or a picture of this QR code, we'd be happy to send you a electronic copy of it free. And it's also available online, hardcover, softcover. It's audiobook on the Audible library, and it's also available as an ebook in the Kindle library. So if you know somebody who would benefit reading this software leadership book, then you can just send them the link as well, and we'd be happy to even send your whole team a copy. Okay, let's keep going. So I had the pleasure on my podcast a while back this year to interview Jeff Sutherland, who was one of the main instigators in Scrum, and he was using kind of the Scrum philosophy and practices before it actually became Scrum in the 70s. And I was able to to interview him, and he told that story. And you can just go to the Azure and DevOps podcast wherever you get audio on all the audio podcast channels, and then we're on YouTube as well. You can search for it; it's easy to find. And one thing he said really stuck with me. He said by 2030, teams are going to be 30 to 100 times faster. And of course, I asked him why, and he said because of the combination of extreme programming and Scrum and artificial intelligence. And he used the term extreme agile. And so, of course, in 2001, the Agile movement came out with the Manifesto for Agile Software Development, and it was in contrast to the big batch processes that were really popular in the 90s. And so we've had, 24, 25 years of the entire software world being completely transformed by this idea that instead of big batches of work, we should move to a single piece flow, smaller and smaller batches, ultimately to a batch size of one feature. And we should be able to take an idea for a feature and go all the way to production without it being hindered or grouped together with a whole bunch of other stuff and delaying its rollout to the customers. And of course, extreme programming in 1999 gave us all of the engineering practices that sprouted continuous integration and that sprouted DevOps automation and the basically bringing the total quality movement to software engineering. And so I I do believe that this is going to happen, 30 to 100 times faster. That's more than just 50% faster or incremental productivity. And the only way that that happens is if there become architecture standards and design patterns and consistency. Because anything that has very rapid and consistent flow has to be standardized. You can't put your hands on every line of code in order to do that. I think we've understood the kind of the bounds of the productivity when a person puts their hands on every line of code, even with really great tools like ReSharper that are generating for loops and automated refactoring and things like that. So I want to focus your brain on the premise of delegating a feature to the computer. And of course, it's my computer. I'm operating my computer, and these AI tools can run on my computer or can run on a remote computer. But either way, I'm delegating a feature to a computer. And I'm going to pop away from PowerPoint just for a second and show you an application that we're going to be dealing with. And this is a very simple work order application themed in the First Church of Springfield. If you've ever seen The Simpsons, and it's just a work order system. Now, this is the production environment. I'm going to go back to our a pre-production environment and log in. And of course, there's no, oh, I didn't put any data in that one. So I'm going to log in as, myself. Actually, that's the same one. Oh, there's an active deployment going. Never mind. I just kicked off a deployment and we're going through. So I am going to show it to you on my local computer. Here we go. Control F5. All right. And I'll show you the link in just a second. And so I'm going to log in as the Reverend Timothy Lovejoy. And there are work orders. And of course, we can assign it to someone and give it a title, a description. And I have just created a new feature. I've added a brand new field on a branch on my local computer. This is brand new, but this is a very simple feature. And certainly on an existing application, I should be able to add a new field to a screen. And of course, the layers in the application all the way down to a new column in the database. And we should, if we can delegate anything to the computer, we should be able to delegate something as simple as that. I can give that to any member of my engineering team, and anybody could do it, and I would have consistent results, right? So if I'm going to take advantage of AI-driven development and add AI agents to my team by equipping every one of my software engineers with the ability to operate an AI agent, then certainly we should be able to take a feature like this, which is just adding a field to the screen, and make it happen in an unattended way. Certainly, I could come in here and I could create a new Copilot chat in the agent, with Claude Sonnet 4.5 or Haiku, and I could tell it to do something and I could sit here and watch it. That's not the point. If I sit here and watch it, then yeah, maybe I can get incremental productivity improvements because it can type faster than I can, but that's not the point. If we're going to equip our engineers with autonomous AI agents, the point is to have them be kind of like background jobs, service workers that are just kind of running off to the side, and they do something without having to be watched. So I think a lot of people are looking at embedded Copilot and Claude and all these other tools, and I'm going to set aside the scenario where you interactively prompt it and then you wait for it to do something. And we're going to jump to what it looks like to have a completely autonomous coding agent. So let me close Visual Studio and shut down our application here. And this is one of the things we're going to do. Okay. Now I'm going to, just because it takes a little bit of time, I have prepared, I'm in GitHub, and this is an open repository. And so if you look in the chat, you can go to this URL and you can follow along if you like to, or save it for later. But I basically have 3 issues that I've put in and I'd like to just delegate them to the computer, delegate them to the GitHub Copilot coding agent. So we have a new three-letter acronym, which is CCA. And I'm gonna go into one of them, and this one is, add the instructions field. And I have the conceptual definition of this. I know the formatting is just plain. We have some details about where to put them, what usage is necessary, some technical design. And I'm not going to read this to you. I'm going to show you how I put it later, but I want to get these kicked off. And I have multiple scenarios of full system tests. Okay. So this is one. And so I'm going to go ahead and assign that guy to Copilot. I don't need any additional instructions. You can add additional instructions if you want to, but I'm going to assign that guy. And let me go back, and we can see that this little guy popped up. Or I can just check these boxes on the other two, and let me assign those guys to Copilot. Okay, now that I've assigned it to Copilot, go ahead and assign, make sure they took, there we go. I can come back to this one, and I can see that it's been picked up because I have a little eyeball. And so Copilot has put that little icon there, and it has created a draft pull request. I can jump into here, and I can see that a session has started. This is actually running as a GitHub action. It's on a Linux VM, and you can watch the session if you want to, but the point is not to watch the embedded Copilot do its job. The point is just to let it run. So if I come up here to agents, you see I have 3 instances of Copilot coding agent all running on a separate issue. Okay. Now, let me come back and show some tools. Okay. Now, if you were to interactively run this same feature, oh, I missed one thing. One feature is adding the instructions field. The other issue is to add an auto logout feature if there's 60 seconds of inactivity. It could be 5 minutes. I just picked 60 seconds, just easier to demonstrate. And then another issue is to add a blinking effect to the login link. I mean, that's like a tiny enhancement, right? But the instructions field actually requires changing the database as well, which is very realistic because a lot of the changes to our applications also require adjustments to databases and other dependencies. Okay, let's jump back into PowerPoint. And if we were to interactively do it on our computer using Cursor, this is what it would look like. So because these take a little bit of time to run, I ran 4 parallel agents inside Cursor to add the instructions field. And this is what it looks like after it's complete. And you can see the list of files that have been edited. And you can also see that .SQL file. So you can see that Copilot, is very successful at doing this interactively. All right, that's what Cursor looks like. This is what Visual Studio 2026 looks like when you use Copilot built into it, and you can see all the same set of files that are changed. All right, this is what JetBrains Junie Pro looks like inside the Writer IDE, inside JetBrains Writer, and it's a little bit different. It has the logs on the right, and it has the plan in the center pane, and it keeps that front and center while you look at it. That's what JetBrains Writer looks like with Junie. And this is what Claude looks like, Claude CLI. And it doesn't even load it up in an IDE. It just literally runs command line and does a pretty good job. This is what Claude.ai looks like inside. No, this is what the Claude agent looks like running inside GitHub. All right, the embedded GitHub compatible Claude agent. And this is what Claude.ai looks like. And this is the same as the Claude iPhone app. It runs in a very restricted Linux container that doesn't even have the capability to run AI tools or call to MCP servers. So it's very, very restricted. So it can't actually run any tests or anything like that. But it does actually do a pretty good job at generating the code. It's just no way to get feedback, which we'll talk about that. Now, if you are going to run these tools locally, I'll make one point. You are going to have to augment your private build because invariably you have some set of SQL files that build up your local SQL Server database. And in this application, we use DBUp from Octopus Deploy. It's probably the most popular database migrations tool. It's free and open source. And so we have updated the private build of this application to be able to run multiple instances of the private build in parallel. And you can see down in the left-hand corner, we have this church bulletin database for our application, but it has timestamps and it has uniqueness, because if I'm going to have multiple working copies or use working trees and have multiple of these agents all running on my computer, they're all going to run the tests and run the private build at different points in time. And if they're all pointed to the same named database, they're going to step on each other. So that is one enhancement you're going to have to make. But let me show you just the differences in all of these coding tools so that we have the right perspective. And I've listed the tool on the left-hand side, the execution environment, the operating system, and a few notes. I want to just jump down to the GitHub Copilot coding agent. That is hosted in a virtual machine in GitHub, and it is running Linux. Okay, it is running Ubuntu Linux. And just recently, all of Microsoft and all the containers and VMs have changed the addition of Linux to be used, but it is using that. And under the covers, it's using the OpenAI Codex model. At least it was, unless they've changed it recently. A Copilot coding agent from GitHub doesn't make any kind of statement about what model is going to be used. So I expect that they'll probably, continue to change that and update it. Although it'd be interesting if they ever chose something that was not from OpenAI, just because of the close partnership that the Microsoft family of companies has with OpenAI. But either way, this is where it's running. So if your application is not compatible with Linux, then you don't have the Copilot coding agent available to you. And even the Claude agent on the iPhone or Claude.ai, those all are going to run in Linux. And I expect more and more of the autonomous agents to be running in Linux VMs or Linux containers. And so you want to look at your application, and if you've never tested it with a DevOps environment that is fully Linux, then you're going to have a limitation there. And so whether it's the PowerShell private build script, if you have any commands that kind of you think that they'll run on Linux, but you've never tested it, you want to test it just in case there's something that's not compatible. But we're gonna set those other tools on the side and just focus on Copilot coding agent for the rest of this. I put the link in the chat, but this is the GitHub repository that we're working from. And while those coding agents are working away, by the way, if you have this up in a side browser, you can sort of see it going, because it's an open repository. About a year ago, there was a study sponsored by Stanford. I included the link here on the screen. And there was a presentation about the use of AI coding tools. Now, Cursor was heavily used in here because they had such a head start. But what was found was that productivity did go up incrementally. You can see the output units on the side. But that orange block is what I want to call your attention to. And the orange block is the amount of rework that was found when these AI tools were adopted mid-year in 2024. And now that's really not okay, because yes, we kind of incrementally improve productivity, but we materially increase the amount of work. Rework is new work. So there's a mixed bag, and I want to talk about why, because ultimately we want to transform the output of our team by the introduction of AI agents. Octopus Deploy and others recently were sponsored the DORA State of AI Assisted Software Development report and survey, and I'm going to call out one of the results from that report, and it's the estimated effect of AI adoption on some key outcomes. Okay, so we can see some of the key outcomes like individual effectiveness. Hey, that's what, 17% improved. Organizational performance is one of the blue. Blue is good. Valuable work is improved. Code quality is improved about 7%. Burnout and friction, there was no change in how much people experience burnout. There was no change in how much people experience friction in doing the work. Now, look at software delivery instability. That increased by almost 10%. That's not good. That means that with the introduction of AI tools, there was an increase in instability. Now, this is holistic. This is AI tools for generating code, but also AI adoption just generally, such as chatbots and all that. But 10% increase. And if we're going to have some of this code, generated by a bot, essentially, we don't want to increase instability. And so we're going to talk about that. Anytime we talked about stability, we talk about our DevOps environment and the importance of having a complete DevOps environment. Way back in 2006, there was a book that came out called Continuous Integration. And then in 2009, there was a book that came out called Continuous Delivery that included deployments. And then, of course, cloud adoption was increasing, and you can automate environments. And then in 2010, 2011, the word DevOps started to be talked about. And effectively, DevOps was a term that sprouted from some conference talks about agile system administration, how to take all of the advances in automation and quality control that software engineers had figured out in the agile movement and apply them to the work of sysadmin work, system administration for systems engineers. And then, that title was kind of boring. And so, there were some suggestions. Oh, let's call it DevOps. After it was called DevOps, the project management community kind of did to DevOps what they did to the agile software engineering community and kind of co-opted it and made it all about process and people working together and personalities, just as extreme programming was all about test-driven development, and automation and builds and continuous integration, all of the engineering practices that yielded high quality. And the project management group, which was all about the project management body of knowledge in the 90s, that group jumped onto Scrum and said, no, it's about ceremonies, it's about estimation and planning poker and retrospectives and about people working together. And they kind of pushed all the engineering practices to the side and made Agile about a lot of interpersonal things, when really it was about engineering. And so the genesis of DevOps was all about engineering, how to take the engineering from Agile and apply it to systems administration. And then with the rename of DevOps, there was a large crowd that said, ooh, DevOps, ooh, that must mean developers and operations folks coming together. DevOps. We need to work better together. That's what we should do. And kind of bastardized the whole genesis of what was DevOps supposed to be. It's not about Dev and Ops coming together. That was just a play on words. It's all about agile system administration. It's about taking the engineering practices and automation and applying it to environments in the cloud and how to work there. So we come up with a complete DevOps environment. This is the architecture for a complete DevOps environment for .NET systems, with the assumption that we deploy to Azure. And of course, for build server, we're calling out Azure DevOps. For deployments, we're calling out Octopus Deploy. For database, we're calling out Redgate, which are really good tools for database. And it is so important that you have a complete DevOps environment if you want to adopt AI-driven development, if you want to add autonomous AI coding agents to your software engineer's tool belt. It will not work unless you have a complete DevOps environment. Now, you can use Copilot, and you can have your engineers interactively use Copilot to help them do a better job and watch what Copilot is doing and press the keep or the reject button whenever that's all great. Everybody can do that. But if you really want to delegate a feature to a coding agent and sort of push it to the side and then come back later and see if it was finished, you have to have a way for that coding agent to run all of the quality control checks that you have baked into your DevOps environment, your unit tests, your integration tests, your full system tests, and the feedback to know that it will deploy to a environment and that it'll still start up and do what it did. And so let's jump into some of the practices there, and then I'll review it in the working environment. So this is the flow of our builds. We have two types of builds. We have a private build and an integration build. And we're gonna, clean the environment. We're gonna get rid of any temporary files from a previous run. Then we're gonna stamp a version number. Then we're gonna set up our environment locally. In other words, we're gonna create our SQL Server database or what needs to be running on my local computer. And then we compile the code, compile C#, and then we run our unit tests. Those are fast. Then we run our integration tests that go against our database and other dependencies, so a little bit slower. And that's our private build, okay? The integration build adds on some additional things typically. And one of those things is static code analysis. One of those things is publishing the test results to a dashboard. And the next is publishing a release candidate and then, packaging a release candidate and then publishing it to Azure Artifacts or Octopus Deploy or NuGet.org, whatever we're doing there, okay? Then the third phase of continuous integration, which continuous integration has three phases. The commit stage is the private build. The integration stage, the commit stage and the private build script, that answers the question, with what I just did on my local computer, do I still have a stable code base or did I break something? The integration build answers the question, with the code from my other teammates mixed into mine on a completely independent build server, not my local computer, do I still have a stable code base? Does it still work or did something get messed up? That's the second one. The third stage is the first deployment, and that's we're called the TDD environment. And that answers the question, this release candidate that came from this new build, from an integration build that passed, does it still deploy properly? Does it still start up properly? And does it still do the functions that it has done up to this point properly? Because we don't want to find that out when we tell some of our product management group or customers, hey, I have a new build, go check it out, go test it. And then the first thing they do is realize this is totally broken. It doesn't even work, okay? So this is the flow for a pull request when you have continuous integration fully implemented. You specify test scenarios along with the other requirements. You change code. You do the private build locally. You do a commit and push. Then on the build server, the CI build, the integration build runs. Then on our TDD environment, which stands for test-driven development, it is a test automation environment. No humans are allowed on this environment. It's just going and going and going. As soon as it finishes deploying and testing one build, it throws it away and grabs the next one. So it's no point in having any people try to actually use it. It is only for test automation. We do a deployment from our feature branch to that environment, and then we run our full system acceptance test suite against it. And then once that passes, now we have the confidence to know we can create a pull request and then ask for a pull request inspection. Okay, I'm gonna hop away and jump back into Copilot, and it looks like one of these issues is already finished. So if I go to my GitHub Actions and go to my integration build for branches, I can see a pipeline modeled on in GitHub Actions that's first my integration build. Then we publish our release candidate, and then we deploy to the TDD environment. And of course, I can see the unit tests, the integration tests pass. I can see that my Octopus deploy release was created. It was deployed. And I just have a few warnings there that are benign. Okay. Now, if we go to our master branch, I just want to show you all of the actions, quite a few actions, and I can jump over to integration build here to the latest on the master branch. The pipeline, when I'm on the master branch, goes all the way through UAT and production because with the feature branches, I'm not going to deploy a build off of a feature branch to a manual test environment that my product team is going to look at, and I'm not going to deploy it to production. I'm only going to deploy it through our test automation environment. And then once that's good, well, now I can do the pull request process. We can look at it. We can decide to merge it into master. And then we can have our actual GA release candidate do it all over again to make sure that we don't have any merge issues, and then continue on deploying to our UAT environment and to production. But I do that, I merge the pull request knowing that I've already verified that this change is still going to deploy, still going to start up, and still going to run our full system test suite. And then I can continue on deploying. All right. So that's how you model that. Now, if I come back to pull requests, these three, I made copies. Okay. I made copies of the GitHub issues before here because they take a little bit of time. Some are quick, some are take a lot longer. However, this is autonomous. I want to delegate to the computer. I want to delegate to GitHub CCA, and I don't want to even look at it unless I see that green check mark. All right. That green check mark means that all of the checks have passed. So if I were to, let's see, if I were to add instructions field, okay? If I were to come here, I were to look at the commits, look at the files changed, you know, I could review all this code painstaking, but it doesn't matter if I like the code or not until I know that it's stable. And how do I know it's stable? It's because of the checks that the integration build passed, that I published a release candidate, I deployed the TDD environment. And so if I come back, I can see, yeah, and I don't even want to read all this until I see, yep, all the checks have passed. There it is. Because if any of the old tests fail, I don't want to see it. If any of the full system tests, if it doesn't deploy, I don't want to see it. And of course, over in Octopus Deploy, we have our dashboard, and we're just delegating using the integration with Octopus Deploy, and we can see that we have a deployment to the TDD environment from a branch, and of course, we have our master branch that goes all the way to production. Okay, so I can pull off of that. And now let me show you. We need to make sure that these coding agents have the ability to run all of our test automation. So let's go into here. This has the green check mark. We can even investigate what it did. So if I view session, okay, if I view the session, I can look at, just like if I ran it inside Visual Studio directly, and I can see what it did. And so if I scroll all the way up to the top, I can see that it's looking at some files here, and it's okay. Now it's editing. That's editing a few files. It's looking at some new files. It decided, oh, you know what? Let me run some of the unit tests. Okay, 88 unit tests passed. Great. And then it's starting the server application to make sure it still starts up, and looking, and then executing some playwright to take a screenshot. Okay, there we go. And then it is progress update, and then it finished. Okay, so let us pull back and look at the, let's see, there we go. Let's look at what this is doing. Let's go to the workflow file, and I am going to scroll down, and I know exactly where I'm going. So I'm going to scroll down to publish release candidate right here, TDD environment. We're delegating, we're telling Octopus Deploy, go ahead and deploy this release. After Octopus Deploy finishes, then we say, okay, where in Azure is it running? Got it. And now I'm going to run my acceptance test. This is so important. We cannot just delegate to the computer and expect the GitHub Copilot coding agent to do a good job unless we have a way for all of the engineering feedback that we've built for ourselves to somehow get into the LLM context window. All right. And so, what if a test fails? How does the Copilot coding agent context window ever get that data so that the agent kind of knows not to finish working because it's not yet done? And uh, this is why we run the acceptance test. Now, what are the acceptance tests? Well, let's come over to our Visual Studio solution, and inside this project are acceptance tests. And if I just, here's a really simple one, the login tests. This is using Playwright, but effectively, we're just gonna, it's using Playwright to open up a browser and drive it. And let's click the log out link so that we make sure we're not logged out so we can run this repeatedly. Then let's click the login link. Let's type in a text box or select Homer Simpson, H. Simpson. Then we're going to click a button, the login button, and then we're going to make sure on the next screen that we see the welcome text, welcome H. Simpson. That's the structure of these full system tests. Now, if I run them, I'm going to run it locally just so you can see what is running on that Linux VM under the covers that the Copilot coding agency is waiting for. And if any of those fail, those logs go back into it's like copying and pasting those logs directly into your Visual Studio Copilot chat and saying, "Hey, keep working." So my hands are not on the keyboard, and these are the full system tests up and running. And with these tools, with a private build that has a PowerShell entry point that can be registered as an AI tool because these coding agents can run commands. And so you want them to be able to run the private build, which includes all of the unit tests and integration tests. You want, if the integration tests require a SQL Server database, which this application does, then you want that to be included in that PowerShell so that the Copilot coding agent, when it runs it, is actually spinning up SQL Server on that Linux VM, building the schema, and then running the integration tests, which write records to the database and read records to the database, and then runs the full system acceptance tests, which actually uses Playwright on that Linux VM running in GitHub that is spinning up headless browsers. And I have set this to be, I turned the headless off so that it could actually pop up the browser so you can see that, it's a robot driving the application and running through different test scenarios that we have. I think we have, three dozen or so. And so with that test automation, that's a lot of feedback where the logs go back in the context window of the AI coding tool that you're using, and there's the feedback. And only when all of the tests pass is it even worth it to request a pull request review from an actual person. So these are pieces of machinery, pieces of business equipment that I'm operating. I'm operating Copilot in my GitHub account, and I am submitting a pull request to my team. Copilot's not submitting a pull request to my team. I am submitting the pull request to my team. I don't want to waste my time even looking to see whether a particular feature is ready for a pull request unless I know that the software, the code base, is still stable, that nothing else is broken. Because if it is, I don't want to take code in some indeterminate state and then try to look through the code myself and see if anything is broken and then fix it manually. It's actually faster to, I'm going to close this. It's actually faster to kill it, get rid of the feature branch, and just tell it, try again. Okay. All right. I'm going to stop these and kill I'm going to kill all the tests. Yeah, let me stop that because I closed the browser. I don't want to, it takes a while for it to run. Okay. It takes a while for it to run. And yep, kill orphan. Okay. Let's come back to the status of our agents. Oh, it looks like add instructions field, that one finished as well. So we can see if we just go up, okay, files changed. It successfully implemented these. Great. Progress. Building acceptance test project. There we go. And yep. Okay. Very good. All right. So I'm not going to jump more into these, except I will go into the GitHub Actions because I want you to see. Go to summary. I have to go to Actions. All right. I have multiple feature branches going in parallel. So let me go to this one. Multiple parallel branches, and this means they're waiting. They're waiting on something. So wait a minute. Missing using statement. Ah, here we go. So this one right here, auto logout activity. These are some of the minor ones. Okay, so auto logout activity. Yep, went all the way through. Okay, let's go to deployments. All right, I talked about the different categories of environments. TDD, UAT, and production. You need at least one of each of these categories. A lot of teams are going to opt for multiple, but you need at least each one of these. You want to build your release candidate once, you want to package it once, and then you deploy the same thing to each environment. The point is that the point is that you never do anything in production for the first time. You never do anything in UAT for the first time. You do a lot of testing and checks in the test automation environment so that then deployments to your manual test environment are more streamlined. And by the time you deploy to production, you're doing very, very little, and it's basically a no-brainer. Okay. All right. Before I go on to the next slide, let me come back to these issues. Now, I just pasted in a lot of things. You might think, oh, wait a minute. You've got a lot of, do you really have to specify all kinds of this stuff to make Copilot do the right thing? And by the way, I've run these multiple times. Copilot really doesn't have a problem doing these simple features. It actually does a pretty good job. But the times where it doesn't do a good job because it's non-deterministic, the build will fail because it will have broken one of the existing tests, and I'll throw it away, try it again, and it works just fine. But how do I get this text? Well, enter a custom agent in Microsoft 365. Now actually, I'm going to open up this guy and edit. So I showed you at the beginning of the presentation, I wrote a software leadership book called The 5 Pillars Leadership for Effective Custom Software. And as this edit screen pops up, I have some instructions about the application that we're working on. But then I also have uploaded the entire text of the manuscript for my book, and it talks about how to organize requirements and the different design decisions that you have to make. And so I'm going to demonstrate this for you. I'm going to go here and I'm going to work on this feature. So if I just hit Windows H for activating my microphone, and I'm going to think about the feature that I want to build. This new feature is adding an instructions field to the work order create screen. When creating the work order, we want to make instructions optional. It needs to support up to 4,000 characters. The point of this new field is to allow the work order creator to specify how a work order should be completed so that the assignee has an easy time doing the work order and knows exactly what to do. The field should be below description and above room number. It should be a text area on the screen. There also needs to be a field in the database. Let's make the type invarchar 4000. And there's several test scenarios that we need to include. One is creating a work order without instructions and proving it's optional. Another scenario is to create the work order by specifying the instructions at creation time. Another scenario is creating a work order without instructions, saving it, assigning it, and then coming back and adding instructions. And a fourth scenario is putting in all 4,000 characters to make sure that it can support the upper bound. Create a GitHub issue with this feature spec. I just hit the enter key, which stopped the microphone. Okay, and let's just send that into our product management agent. And because this agent has been trained with the architecture of this particular application we're working on and the text of my book, it specifies the 4 categories of design decisions. So there's the title right there. And if we just put this here and this onto the right, you can basically see, now it's a little bit different, but it's the same. It's very similar because I spoke it just out of my memory. The conceptual definition section, then the user experience design, which is how we want to use it. Then the technical design right there. And then the test design, which is the different scenarios. I think for this over here, I only gave it 3 scenarios instead of 4. All right. Now, what about this? What about work tracking? All right. And by the way, with this agent, we typically talk about a feature, and it's really easy with an agent like this just to record the transcript of a conversation, pump it in here, and armed with the architecture of the application, you have a spec that's ready to go for one of these autonomous coding agents, and it saves us time because all of this information, and I've looked through piece by piece, when you put the vice on the large language model and make it so specific and pump in all of the information about the architecture by attaching architecture documentation and whatnot, all of this is actually correct. This is not hallucination. If you had no context and just went to ChatGPT and just said, well, it's guessing, well, what is a work order application? What does it mean? But because I've put in this agent the architecture of this application and some of the documentation of this application, there's no hallucination. It's very, very, very specific. Okay. Now, what about requirements analysis for AI-driven development? Well, this is what your Kanban board should look like. No, not specifically. You're going to have different things. But if the middle column is where the code gets written, development, and the columns before development are for requirements and design, and the columns after development are for testing and validating the code, then it stands to reason that the columns before development make the actual coding easier, right? And by the way, this is in my book. You don't have to read all of it, but I'm going to go over the 4 minimum design decisions that are necessary to make sure that the code gets written the right way. And interestingly enough, these are the same design decisions that are necessary to make sure that any engineer on your team actually has everything necessary to build the right code without having to stop and go ask somebody or based on their personality, assume something. And when you have all of the information, when you've actually made all the right decisions, then you unlock the power of these completely autonomous, under the covers, unattended coding agents like the GitHub Copilot coding agent. All right, so this is the left half of the Kanban board. The first is conceptual definition. And this is the concept we're thinking about, or the business objective that we have. This is where we do the business level design, the why, the what, the by when, the for whom, what is the goal, what are we trying to accomplish, what non-technical outcome is desired, is there an acceptable ROI, return on investment, what customer group needs something, what are the constraints? Okay, we have to decide those things. And then we move on to user experience design. And this is where we ask, where, how does a person do it? This category of design generates options for how it might work. And then we select one. there's always going to be multiple options for how it might work and how someone might go about experiencing this change in the software. But this is a stage where we disqualify options that don't meet the constraints that are already been identified. And if the option includes something visible, like a screen, then we create a wireframe or a screen sketch, and we do that design. Even if it's invisible to the eye, if the design is invisible and there's nothing visible, every software change will be experienced by someone in some way. And this design category determines how a user or a stakeholder of the software is going to be affected by this feature or change. And later, when we do user experience testing, some call it UAT for user acceptance testing, then that's when we're testing that these design decisions were actually implemented properly. Here is where we decide what the observable behavior of the software should be to accomplish the objective that we're working on. Then we move on to technical design. To do this completely, we need to decide what architectural elements are needed to implement the chosen solution. What must change in the software? How many individual development tasks are required to make this change a reality? This design category creates an implementation plan for the feature by breaking down the work into smaller chunks or little tasks or a little list that can be assigned to a software engineer or a coding agent and have some hope of being completed quickly. Invariably, some of these features are too big and need to be broken down. This is where we break it down into individual things because, well, you can't have a feature that's too big assigned to one software engineer and expect him to actually do a good job and it be done in any kind of reasonable time. Same thing with Copilot Coding Agent. You need to break it down into discrete changes. Okay. Then the final design decision before coding starts is test design. In this stage, we ask the question, when is it done? What's the definition of done? This is the decision point for knowing whether or not a new feature is finished, what is in scope, what is out of scope. Every software feature has more than one pathway to experience it. And by listing out the usage scenarios, we can understand what to check for to make sure it's actually done. And having a list of usage paths gives us the list of full system acceptance tests that need to be coded as part of the coding of the feature so that we have an ever-growing test suite of full system acceptance tests. Okay. And now when you run through a feature like this in through a complete DevOps environment, then you get a feature that is complete and is ready for testing. And you also know that the code base is still stable and things that used to be working are still working. And that, my friends, is the definition of increased team throughput because we took a feature that we would have had to code ourselves just like normal, and we were able to delegate it to the computer and see that it actually worked. It actually did a good job. So if I go back to Visual Studio and I have pulled the branch of I've pulled the branch of one of these that I ran through and so if I go to excuse me, if I go to the test that loads up some data and I just run this test, it's going to reload the local database with my test data. And there we go. And if I Control F5, run this locally, open it up, login, Lovejoy, I can create a new work order, and there we have instructions, a new field, and I can specify instructions, and I literally didn't write any of this code. And the final thing that I'll leave you with is if I go through here and let's go instruction field. Okay. I'm going to go to the pull request because that shows the actual code. The question is, okay, The code's still stable. I didn't break anything. I think I'm ready. But what if the code is crap? Let's just go there. What if the code is terrible? Well, let's go to Files, Changed, and let's review it with our own eyeballs. So this is a new acceptance test. Okay. This is a new acceptance test, so it's going to be a new file. And actually, I'm going to come back to the acceptance test because working outside in is probably more easy on your eyes. Here's our work order class. I have a new private field. I have a new property that, basically uses the same helper function as we already have specified, and that's it. I have a work order map because I'm using Entity Framework. And so this is the only line change on our Entity Framework mapping. That makes sense. I have a new .sql file that is binary national. Okay, view. Can I open it here? View file. There we go. Here is, we're going to alter table work order. We're going to add instructions in varchar 40. It's going to be nullable. And that's it. Okay, fantastic. So if I go back here, all right, and now I'm in the UI. So work order, here's the markup, just like I have. Yeah. So I have a new div, this is the same pattern in the screen, and input text area. There we go. And we even are using our pattern for our page models for playwright tests, elements.instructions in our data test ID, so we can have a good test handle. And we're specifying instructions in our elements enumeration. Here's our code behind file where we're setting instructions to work order.instructions. This all looks like code that came from a real person. So I'm liking it so far. And if I just scroll down, if this were to come from a real person, I would say, okay, that's reasonable. There's no hallucination, no crap here yet. All right, and then work order test. And now I'm going to come back to our acceptance test and see, okay, should create work order with 4,000 characters. Okay, let's see if it does that. So we're going to create some things. All right, wait for it for loading. Then we're going to click on new work order. Then we're going to expect the work order number to be visible. Okay. Then we're going to input title, description, instructions, room number. And I think up in instructions, yep, we're creating a 4,000 character long instruction. So that's okay. Then we're going to click the save button ID, and then we're going to wait. Then we're going to, from the database, I like this. It's using patterns we already have. It's going to use our data access layer and is going to load up, and it's going to make sure that the instructions length is 4,000. That's a very reasonable test. I mean, the only thing that I don't like about it is a task.delay 1,000. So when I'm doing the pull request and I'm looking it over, there's one thing out of this entirety that I didn't like, and that was the task.delay. And you know what? With that tweak, I'm done with this feature. So that's pretty impressive. All right, so let's kind of wrap it up. I'm really excited about the prospect of taking easy features and be able to enhance our DevOps environment with these automated AI coding agents that can take super easy features that I would have to do myself. I know exactly how I'm going to do them. There's no mystery. They're not hard. The patterns are already in the code base. And now I want to take those easy ones and I just want to delegate it to the computer and know that when a pull request is available there with a green check mark and it's ready for review, that I'm looking to see if I like the code and if the feature is complete. I'm not looking and questioning, was there anything else broken? And so you have to have a complete and robust DevOps environment to be able to funnel logs back into the context window of these coding tools so that none of these tools report success and finished if there's something broken. That's important because stability has to be the top priority. It doesn't matter if we ship faster and deploy faster if we just ship bugs to our customers faster. So I hope that you got something useful from that today. And if you have any more questions, we love helping teams adopt AI-driven development and to get better and be more effective and deliver world-class results for your customers. I'm so glad that you all are here, and Merry Christmas and God bless.